Okay, so in this video, we'll look into one more table or database, employee department database in your book. Um, okay, so create database employee DPT. Let's do it like this. It's there, not there, so it's created. So use empdpt, so you can get inside this and create tables. So these are the two tables we want to create. The employee table will have employee number, e-name, salary, bonus, department ID, and department table whose structure is not given in the book, but it's basically department ID and department name. Okay. Um, okay, so let's create the department table, which is simple. So let's say create table department. And department ID, as you can see in employee table, it's basically like this. So it could be char of 3. Now here I'm going to show you the use of the alter command to create primary keys, foreign keys, and to add some constraints. Okay. So let's just put a comma and the department name, varchar of say 30, and again we can add some constraints using the alter table. Okay, so this closing parenthesis for department. Okay, we have created the table. So let's use the alter command to add primary key first to the department table. So the department ID will be the primary key, and we'll make the department ID in the employee table as the foreign key corresponding to that. So alter table, the table name is department. Now for primary key, foreign key, and uniqueness and constraint, we want to use a keyword add. For modifying the data type or anything with an data type with an attribute which is already there, you have to use modify. So for primary key addition, you have to use add, and you want to add department ID as the primary key. Before that, you have to specify primary key. So add primary key of. So alter table, and those are keywords. Department is a table name. Add is again a keyword. Primary key is a keyword with a blank space in between. Department ID within parenthesis and put semicolon. So that would have added the primary key. So if we now describe department, it would list the primary key to be the department ID. Now for department name, it doesn't look good to be allowing null. So you want to make it to be not null. So you can say alter table department, and then want to modify this because it's already there, the attribute. So say modify department name, and even though you're modifying it to be not null, it's not sufficient to just say not null. You have to put the data type also as if you're creating that attribute. Modify department name varchar of 30. If it's the same thing, or this is the time if you want to change it to varchar of 40 or varchar of 20, you could do that here as well. And then let's try. Let's make it varchar of 35. And then we can also put one more constraint along with it. So we can make it not null. Okay. So this way both will get changed. So if you describe department, it's now department name is varchar of 25 and it's null. Null is no. So department name cannot be null. Okay. So let's create the employee table and also use alter command to incorporate some constraints. So create, let me do it in the top. Create table employee. Now emp and o is an int, and that will be actually the primary key because the other attributes could be duplicate and some could be null as well, like the bonus. So we'll make employee number as the primary key, but we'll do that using alter command. Let's say int now. E-name, again, it's like the name of the employee could be varchar of 30. Varchar of 30. So we'll make it again not null using the alter command. If you want, you could put it here as well. Okay. Now, salary. Okay, so salary is an integer, so we'll add a constraint of salary in the using alter command. Let's just put in comma. And bonus is also an int. So we can put a comma. And department ID is char of 3. And you have to link it as a foreign key using the alter command. Okay, now let's say alter table employee, add primary key of empno as the primary key. Okay, then alter table employee. Now I want to incorporate a constraint that salary has to be, say, if you see the range of salaries is at least 10,000 and maximum of 60,000. So let's say salary has to be at least 10,000 and make it 5,000 if you want to go less than that. So 5,000 to 75,000. So you can say add constraint is the keyword, and then check salary, evaluate salary, anything as a name of the constraint. So you could name anything you want as for the constraint name. So this is add is a keyword, constraint is also a keyword, and give a name for the constraint. It could be anything, one single word. And then within parentheses, it's like a function. There's a keyword called check. Now I'm not sure where to have parentheses. I don't think there should be parentheses. Let's try without parentheses. Okay, check off. Okay, I think this is the syntax. Let's try. Check off salary greater than equal to 5,000 and salary less than equal to 75,000. Good. So this is a syntax for adding the constraint. Alter table name, add keyword, constraint keyword, evaluate salary is the name of the constraint you want to pass, and just a blank space after that, and then check is a keyword. So you want to check. So this is where you pass the attribute or the condition of the attribute that you want to check. So you want to check the salary has to be greater than equal to 5,000 and less than equal to 75,000 when they pass input. So when you insert into the table, the salary does not meet this constraint, it will generate an error. Okay. Now, similarly, for bonus, you can add a constraint if you want, or you can pass a default value if you want. You already saw how to pass a constraint. So let's pass the default value. So alter table employee, add not add, is modify. So set a default value for an attribute that's already there. So modify bonus is an int. Now, if you want to change the data type, you can do that as well. Now, if you calculate bonus as say some 5% of salary or something like that, it will have some decimal place. But here it doesn't have any decimal place. It has only 3 digits. Let's say we have the decimal place and 2 decimals after the decimal point. So we'll probably have 5 digits. So let's say numeric of 5, 2. Okay, or you can make it 6, 2 in case you want to allow 4 digits for bonus. And then if you want to make a default value of 0, you could do that, default 0. Okay. I think this should do. Okay, so select star from employee because it's empty because we have not inserted it. Let's say describe employee. So see how it says. So 2 decimals after the decimal point, 2 digits after the decimal point, and then the leading is 0. You can accommodate up to 4 digits before the decimal point. So from int, the bonus is now decimal of 6, 2. Okay. You can also make it numeric if you want, but that's what it is. Actually, it is equivalent. I passed numeric, but it says decimal, so both are equivalent. Okay, so numeric of 6, 2, same as decimal of 6, 2. And department ID is char of 3. So between the two tables, department table doesn't have So if you describe department, it doesn't have a foreign key. So we have to also now set the foreign key for the employee table, alter table, employee, add foreign key of department ID. This is the employee table, foreign key, references, department of department ID. So it references the department ID in the department table, which is the primary key there. The foreign key is created. Okay. So I can do one thing. I can add a column attribute to the department table, say location or something, and then show you how to remove it, for how to rename it and how to remove it as well, because it's not really needed, but let's just add one. So let's say alter table, department, add attribute, add location, it's varchar of say 20 or 40 if you want. And do that, describe department, it will show that. Now you want to rename this to lock, LOC or something like that. You can do alter table, department, rename a location, that's old name, to lock. Let's try this, should work, I think. And let's see, alter table department rename. Let's try change and then search for it. Okay, let's see, rename. That's alias, okay. That's what I did, alter table. Rename location to. Okay, I had to use column, okay. So this is a department table location added. So I want to rename L location to LOC. So the way to do is alter table department, rename, everything is fine so far. Column, you have to specify column explicitly, rename column as a keyword, location to LOC. So that got changed. So allocation is not LOC. So we have to also specify the keyword column. So alter table, both are keywords. Department is the table name, rename is a keyword, column is a keyword, location is the attribute name that you want to change from to is also a keyword to LOC. Okay. Now you can even change the table name if you want, but that's not part. I think that's part of in your book. Okay, let's try rename table department to DPT. Yes. So show tables, show department of employee. I can rename it back, rename table department. Now that's the correct name to department. That's fine. So show tables will show you this. Okay. So you can rename table, but you should not use alter. Only if you want to rename an attribute, you can use alter table attribute and all these things. So I think with that, we covered all the uses of alter. Let me see if there are any other uses of alter. Um, Okay, default value we added, remove, you can also remove an attribute. Okay, describe table, department. Okay, so alter table department, drop LOC, will drop that attribute. It's gone. Drop is the keyword. You can also say drop table and the table name, it will drop the table as well, but you have to be careful in dropping tables. Okay. And similarly, remove a primary key on a table if you want to. So, and then if you want, you can add back here. So let's see. Alter table department. But you already said the department ID is primary key for the corresponding foreign key in employee. So if that's the case, you cannot remove it. You have to first remove the foreign key dependency and then remove the primary key. Okay, so that's not again covered in your book, so we don't worry about it. But if the foreign key primary key relationship has not been set, and if it's just a standalone primary key for a particular table, you can remove that. You can just say alter table department and then drop primary key so that you drop the primary key for that table, like it's mentioned here. So for the guardian table, again, before creating any foreign key primary key relationship, you could drop it. And similarly, you can drop a table using drop table, table name, and drop database, database name. So I think we are done with that. So let's insert some records into the employee table. Before that, we have to do in the department table because we have department ID in the employee table as the foreign key. Okay. So now the department table has department ID and department name only. So I can insert easily. Insert into department values. It should be in this format D01, D02, and also it's a char of 3. So we can double quotes D01, say again, string computer science. And D02 is say chemical engineering. And D03 is say mechanical engineering. D04 is say electrical engineering. D05 is say information technology. Yeah. So now select star from department. Now you could also pass some queries on just this one to refresh. Select say count of star from department where department name like, so we want to just say which are the how many engineering departments are there. So again, putting a percentage in before the engineering and after engineering will mean like anything that has engineering in its name will be picked up. And when you put star, all the rows will be considered for that counting. So just put a semicolon. So there are 3 departments that have engineering. Um, Now let's see if you want to see anything that's not engineering. I think you can put a not in front of the line. So there are 2 departments that are not having engineering in their name, which are computer science and information technology. So department name is a string, so you can compare that with a pattern text like this with a like and not like. Now a particular character, we have to use underscore. Okay. Um, let's see. Um, We'll do that comparison evaluation later. Let's do insertion into employee table. Okay. Insert into employee values. One again, I'm just passing for all the columns, so I don't need to specify column names. Salary is 10,000. Now the bonus, I think we set the default to 0. So let's calculate bonus based on, let's make a change. I'm passing only for everything other than bonus. So let's empno name salary. We'll use the update command to calculate the bonus. So the department ID is this. So I'm passing only for these 4 columns. So the salary and department ID, which in double quotes is D03, is inserted. Let's do this. Then 102, 60,000 as a salary, and then D01. Then 103, 45,000 as a salary, then 104, 19,000 as a salary, then 05, 34,000 as a salary, in 106, 48,000 as a salary, and 107, Verghese, 15,000 as a salary, D01, 108, $29,000 is a salary, 109, 42,000 is a salary, 110, 50,000 is a salary. Okay, so let's say select, start from employee. The bonus, we didn't set it, we didn't insert, so it's by default taken as 0. Now let's print first the employee name and the corresponding department name using the join approach. So select, since you're joining 2 tables now, you have to use the table name along with the column names. So select employee.ename, comma, department name from employee, comma, department, and the joining using the where clause, where employee dot department ID equals department dot department ID. So you join using the primary key, foreign key relation between the 2 tables. So these are the employee names and the corresponding department names. So let's say we want to go a little bit in detail and see, want to count the number of employees in each department. Okay, so select again star from, okay. So let's see, select star from employee. So the employee table has a department ID, right? So let's see first how many departments you're spread across. You can get that using the distinct keyword, distinct department ID from employee. It will print 5 because it's and 5 department IDs. Okay, so if you put count of that, it will print 5. If you just put distinct department ID, it will print the actual distinct values, like in this case D01 and so on. Now, what we could do is we could group by the employees and do some aggregation. So I want to now know, based on this employee table, how many employees are in each department. So I can do that, select department ID. I want to print the department ID and the count in each department. So count of, we can say star if you want, or just say count of department ID from employee. Now I want to do what's called group by. So in a group by, that's a clause that you can add, group by. You have to use a particular attribute from the table, and I am grouping by department ID. So that attribute can be alone on its own. So I can put department ID. Okay. So I'm grouping by department ID. So let's just print out what it says. So I'm grouping by department ID. So department D01, it is 3 employees in D01. It's counting how many are in D01. That is 3. D02, it's 2. D03 is 1 and so on. So now you have to be careful with this group by clause. I am printing the department ID. Now, since this is aggregation based, counting is also an aggregation function. So you can pass any aggregation function like sum, count, min, max, AVG for average, it will do that. You can do that, but you cannot say in this case, call for an individual variable like e-name. So, or salary, let's say I want to do salary. So if you call for printing salary along with department ID and the count of department ID, it will throw an error because the aggregation, the group by is done based on department ID. So you can have that attribute on its own there, and then count of department ID. That's fine. But salary on its own cannot be printed because you have to aggregate things. So salary on its own is not aggregatable. So it will still throw an error. On the other hand, if you want to find the average salary of all the employees in that department, we could do that. So we can say AVG of salary. That's fine. It will print the average salary of employees there in each department. Okay, and the count which we already have. Now, if you want to round it, we can do this rounding business here. You can round average salary to say 1 decimal precision. It will print like this. You can round it to 0 decimal precision. You can round like this. Okay. And also, instead of displaying the caption as the function called, we can have an alias as AVG salary, something like that. It will print average salary. Okay. Now, so let's say we want to do some more filtering. So I want to, let me just clear it like this. I want to print only those departments details that have 2 or more employees. So this grouping by is doing this so far. Select department ID. and then the average salary as a count department of ID from employee group by department ID, right? Now, you can add to this group by a having clause. So among these results pulled out by group by, you want to further filter some rows. You can say having some of any of these values can be you made use of. So let's say I want to say count of department ID greater than 1. So I want to print only the details of those departments that have more than one employee. So having will do that. It will filter the results pulled out by group by further, and you have to make use of one of these columns that you're printing out. Okay, in this case, I did having count of department ID greater than 1. Instead, let's say I want to print those departments whose average salary is greater than 30,000. So for that, I can call this round off as salary or comma 0 as all those things, but I already have an alias. So I can use having that alias name, average salary, and case doesn't really matter, greater than 30,000. So this will now print the department ID, the average salary, and the count from employee, the group by department ID, having average salary greater than 30,000. Okay. Now you can also order by something. So you can order by, say, print in the increasing order of salary, the average salary. So where should we place the order by? So from is there, no where clause so far, so let's leave that. Group by department ID is there, having. So having has to immediately follow group by. You cannot use having anywhere else. So it's better to put the order by at the end. Order by average salary. If you print average salary alone, it will print ascending order. If you put DESC, it will print in descending order. Okay, so that's something you can do. Now, let's say I want to print all these details along with the department name. So here is where I have to do joining. So far, I did everything based on employee, right? So let me add join. So in order to join, we have to first prefix these with the table name. So this has to be department dot department ID, round of not department dot employee, right? Employee dot department ID. It's there in both the tables anyway. So employee dot, so far we did one with employee. So let's do that. So employee dot salary, that's average salary, count of employee dot department ID from employee group by employee dot department ID, having average salary, everything is fine. So now I want to print the department name along with this department ID. So I have to get it from department table, department dot department name, comma. So I have to now introduce a where clause because I'm joining. But before that, the from clause, I have to include both the tables from employee, comma department, because I want to pull out the department name from department table. Now, the where clause, the rule is, has to immediately follow the from clause. So you cannot put where after the group by or after having, after order by, nothing like that. The where clause has to immediately follow the from clause. So here's from employee, comma department, where, that's where joining based on the primary key foreign key, where employee dot department ID equals department dot department ID. So it could be either way, department dot department ID equals employee dot department ID, or like we have here, employee dot department ID equals department dot department ID. So this will do this. So here I'm printing the department name along with the department ID using that joining thing, along with the average salary and the count. So we can use alias for the count also if you want. Here, count of employee or department ID displayed as simply count, and it will just display as count. Okay. Now let's see, select star from employee. Let's play with the bonus. So now I want to update, set the bonus. So I have to use update command, update employee. No need to, I should not write update table employee, just update the table name. Then the set is a keyword, which column the bonus equals, let's say 12% of the salary, like that. Then select star from employee will display all the bonus as 12% of the salary. Now, if you want to round the bonus, we can do that. Um, Not here. The display. So if you want, you can display the bonus by rounding. Okay, but let's not focus on that. Let's use a conditional thing now. I want to give, say, 20% bonus to those employees whose salary is more than, not 20. I want to give 20% bonus to those employees whose salary is less than 30,000. And if their salary is more than 30,000 or greater than equal to 30,000, they will get only 10% bonus. So some cutoff has to be there, right? So select, not select, update. So change any variable attribute value, you have to use update command, update employee. Okay, so update employee, set bonus equal to. So here I have to use like an if else right thing, right? Because if the salary is less than or 30,000, I want to do 20%, greater than or equal to 30,000, I have to do 10%. So the thing is, there's a case and it's like a case switch case block in Java and C++, but there's no switch command here. So switch, it's like a case end block. So within this, you're doing the comparison using like if, then, else, and all these things. But here it's just like when the condition is salary less than 30,000, then. So it's when, then, like if, then, it's when, then here. When the condition salary less than 30,000, then you want to set bonus equal to, it's already waiting for the expression. So just write the expression 20% of salary. Now, there are only two conditions, get less than 30,000, 20%, else, no when then, else bonus equals 0.10. There's the expression for else, 10% of the salary, and then the end. Okay, so select star from employee. For those receiving less than 30,000, like 10,000, it'll be 20%, so it's 2,000. Those receiving more than 30,000, like 60,000, greater than equal to 30,000, 60,000, 10%, so its bonus is 6,000. Okay. Let's do a little bit more. Let's do one more level of thing. So I had, let's say, if the bonus, so if the salary, if the condition is like this, salary is greater than 50,000, the bonus has to be, say, 10% of the salary. Salary between 30,000 and 50,000. Bonus is, say, 15% of the salary, and salary less than 30,000. Bonus is, say, 20% of the salary. So then you have to have two else blocks. So less than 30,000 we already have. Let me do it from the beginning. So update employee set bonus equal to, so you have case followed by an N, that's the template. Now when salary less than 30,000, then the expression is 0.20 times salary. Then when salary greater than equal to 30,000 and salary less than 50,000, then The expression is 0.15 times salary. Else, that means greater than or equal to 50,000, 0.10 times salary. So the last thing you can have just with else block. You could have another when, else is optional actually. If you want, you could have another when then here as well. Then you have to specify when salary greater than or equal to 50,000, then 0.10 times salary. Okay, so you can select start from employee and check that. 10,000 guy still gets 20%, 60,000 guy gets 10%. In between, say 45,000 guy gets 15%. Okay. All right. If there's only one condition, we can do it like this. Okay, everybody gets 12% salary. All right. Now let's find a little bit more. Let's see. We want to print the average salary. We printed by department, right? So let's do the same for bonus. Let's print the average bonus received by employees in each department. Okay. So let's say first department ID, comma, average bonus from employee, group by department ID. So group by DPTI, department ID. So this is how it prints. So let's round it. Select department ID, average of bonus, but now I want to round it to 0 decimals. That means it will just print the integer part of it as bonus or something like that. From since it's the same column name, let's give a different alias. This is average bonus anyway. So average bonus from department, group by from department. So no where class here, just from department, group by department ID. Oh, this is department, it's employee table. Okay, let's clear it up. Select from employee. Select department ID. Round average of bonus to 0 decimals, which means just the part before decimal point as average bonus from employee. This is employee table, not department table. Group by department ID. So it prints average bonus. And this is the alias as average bonus. So now using having clause, you can list only those departments that get at least, whose employees get at least average bonus greater than equal to 5,000. Let's do that. So select department ID, round off AVG of bonus, comma 0 as average bonus from employee, group by department ID. Now having average bonus greater than or equal to 5,000. Okay, so it will print only those. Now if you want to order by average bonus, descending order. Now if you want to incorporate the department name to it, you have to join. So this is the employee table so far. So let's put employee dot department ID in front of every attribute first, and then we'll introduce department variable from employee, group by employee dot department ID, having this, that, and so on. So now let's introduce department. So department dot department name, round this thing from employee comma department. Okay. This should do. Let's see, group by. This is the point. I didn't complete it. So I said I'm grouping, right? As well as I want to print the department name. So I have to do join. So the joining has to be done using the where clause. So I have to use the where clause. select employee or department ID, department or department name, round and all these things from employee comma department where how you join employee dot department ID equals department dot department ID. So you want to bring joining the information from two tables, you have to use the where clause to join. Don't forget that. From the two tables, the where has immediately follow the from clause. And then the where clause employee department ID equals department dot department ID. So now you have the name. Okay. So joining, you have to use the where clause, make sure. All right. Let's see. Select staff from employee. Now let's play the string ename a little bit. I want to print all those people like the rhyming names like Sanya and Tanya, Anya thing. So select, say star from employee where ename like, now just one character at the beginning and then Anya. So blank space, ANYA, it will print Sanya and Tanya records. Okay, ename like blank space means just one character will be pulled up and then ending with ANYA, which is Sanya and Tanya. Now you can also do where rename ends with A, then whatever be the characters, it should end with A. Then it will display Alia, Kritika, Sanya, Dariba, Tanya, all those things that end with A. Okay. What else we can do? Select star from department. Now we should also know that we can do substring extraction just for anything, not with just attribute names. You can do with attribute names, but let's say select, let's say substring of the main string, let's say Natarajan. And then starting from a position, I want to extract so many characters. So let's starting from say index 3. So counting starts from index 1, 4 characters. It will print Tara, T-A-R-A. Okay, it's 1, 2, and then third character is T-A-R-A, 4 characters starting from the third character, T-A-R-A. So you can also call this using the mid function. So actually before that, SUB-STR or substring both do the same thing. Okay, sub-str or substring do the same thing. And also mid will do the same thing. Okay, so all are equal to each other. Now, one more string function. I want to say in str, in a string where a particular substring is starting. So, for example, select in str, say this Natarajan, where this age Rajan say is starting. So it will print 5 because it's starting from the index 5. 1, 2, 3, 4, 5. That's where R is starting Rajan. Okay, so using these things, you can do a lot of string processing. So let's say somebody's email is, say, Natarajan at hotmail.com. So I want to print just a Hotmail thing. Okay. So in str of Hotmail, Natarajan, that thing, the second argument is Hotmail. So it will return, let's see what it returns, 11. That's where this H is starting from. Okay. But if you put at in front of it, it will return 10 because that's where the at is there, right? And that's the only substring here. So if I want just the username, say Natarajan, Then I want, there's a function called left. So select, so I want to print from the left, how many characters? In this case, I want 10 characters. So from left of this natarajan@hotmail.com, that's a string, comma, I have to specify, if I put 10, it will print, not 10, 9, because at is starting at 10. So this previous character n is ending at index 9. So if I put 9, it will print just Natarajan. So from the left, it will pull up 9 characters. So from the left, it will pull up 9 characters. So this at is at index 10. So I figured out that the previous character should be at index 9. So I can pass left of the string, comma 9. It will print from left 9 characters. Now, similarly, you can say from the right, say 3 characters, it will print pull out that com from the right 3 characters. Okay. So what you can also do with this is, so you can get this 9 using the INSTR function. You don't have to physically look at the string. INSTR, the same string, natarajan@hotmail.com. For this string, when the at is where the at is starting, -1. So that will get you. So in str natarajan@hotmail.com, comma at will get you 10. -1 will get you that 9. And then you can call that on left of that value, the string, comma 9. So it will print out the Natarajan again. So you can do all this kind of things once you get an understanding of the string functions. Okay. Now all these things can be done on the attribute values also. So select star from, say, department. So let's say I want to get just the engineering department names, but not with engineering and engineering. I just want chemical, mechanical, electrical. So what we can do is select department name, not department name, not let's see. In str of department name, engineering, can include with the blank space as well. From department. So this will print just for the 5 departments. So things to make sense, let's print the department ID, department name, just to keep track of things. So there's nothing engineering in computer science, so it will print 0 from there. For chemical, it will print 9 because this is 1, 2, 3, 4, 5, 6, 7, 8. So the blank space is starting at 9. This blank space is starting at 11. This blank space is starting at 11. The blank space here is no engineering, so it's starting at 0. Okay. So now let's do something. So this will get you the where the blank space engineering is starting, but you want to extract only those for which this blank space index, starting index is 1 or more, right? So you don't want it to be 0. So let's try the alias approach as starting index or something. Don't think it will work. Let's try. Only if you do alias, it will work. You may have to do again this INSTR of department name. We tried earlier, remember? So engineering greater than 0. So it will now print those things. Okay, so passing starting index for this won't work. Let's try. I don't think so. Because you can okay, in where clause you cannot use other than a column. So starting index is not a column, so that won't work. Okay. All right. Now I want to filter the department names. So from left of department name, comma this -1. So it will print only chemical, mechanical, electrical. So I want to relabel as engineering department. Okay, something like that. Okay, so playing with the string functions basically. So we did update, we did joining. Let's see. Now the in thing. Okay, select start from employee. So there are 5 departments, right? So I want to pull out those departments like D01, D02, and D03. Select star from employee. Where department ID equals D01, I can say, or department ID equals D02, or department ID equals D03. You can do like that. Instead, I can say in within parentheses D01, comma D02, comma D03. Only those. Now, I may not know the department IDs, but I know the department name. That's the tricky part. Okay. So how to do that? So the employee table has only department ID. So you can pull the employee records only from the employee table, and it has only department ID. It doesn't have department name. Department name is the department table. So I want to get this D01, D02, and D03 from the department table by passing the department names I know. So I can, and that will be the retrieved values for department ID from the department table. And this department ID in the employee table can be matched with those retrieved department IDs from the department table. So I can replace this with select department ID from department where department name, okay? And there again, you can say like, because you may not know the exact names, but the name of the, you can also say like engineering, for example. Okay, so like percentage engineering. So all the engineering department IDs. Right, so select department ID from department where department name like engineering. So this, since within parentheses, this department name will be implicitly from the department table. This department ID will be from the department table. So it will print those engineering departments because D01 is computer science, D05 is information technology. So it is D02, 3, 4. Engineering departments. So it's printing their employee details. So this is very useful. So the in clause for the where you want to pull out some records from one table based on an attribute like department ID from the employee table, but you don't know the department IDs of specific engineering department. So you try to get it from the department table, the corresponding department IDs by passing the department name that you know. So in this case, just engineering. You want not like engineering, that means computer science and information technology. Okay. Now you can do group by here. Let's go back to like engineering. I think it will be a little confusing. So let's see. So you want to group by and say, let's find the average salary. of which we did each department before, right? Yeah, we can do like that. We don't need to go through this approach. Let's do so this is a good case where you can have in department ID thing. Okay. Anyway, let's see what else is there. Um, we did order by null is just checking is null. Now, for anything plus null is also null. Okay. We did all these things. I think we were good now. Uh, let's start from employee. You can also do something like this, min, max, and average select. You can find all the metrics and some for each department, right? So let's print the department ID, comma, min of salary, max of salary from employee, group by department ID. Because once you use the aggregate function like min or max, you have to group by a particular attribute. In this case, using by department ID, and that's what we're listing here as well. So we'll print for each department what it is. So now you can call the corresponding department name. This is just for practice. Select employee dot department ID. So basically, in this thing, you can prefix the employee table name. Now I want department name as well. So department dot dpt name, comma, min of employee dot salary, max of employee dot salary from, I want to pull from both the department, employee and department table. Now important, you have to not forget to join them where employee dot department ID equals department dot department ID, and then group by department ID. Or it's not DEPT, department dot department ID. Department is a table name. Okay, that's a min salary. So we can pass alias if you want. So again, join employee dot department ID equals department to department ID. Okay, now the alias as min salary and max salary. That will print nicely. Now you can use having clause if you want and pass a condition based on the min salary maximum. The only thing is the where clause cannot take the alias name. The having clause could take, or the order by can also take. Okay, so let's see. Group by department ID. Now when you use having, it has immediately follow group by. So having, let's say min salary greater than say 15,000. It will print only those departments where min salary is greater than 15,000. Then let's say want to order by max salary in descending order, it will print like that. Okay. All right, so let's see if anything is there. So group by is very important, having clause, then we did this. Okay, stop with this.